Off to the races. Hey everyone, let's talk about pseudocode. So, um, I think most of you on the call have done at least some of the pseudocode exercises. Can I have some brave volunteer give me a description of what pseudocode is?
I guess it's just basically the logic without any syntax at all. So it's just pure logic.
Pure logic, no syntax. So we're like intentionally trying to have as little syntax as possible in the code, and really bring to the surface the logic of what's happening. I mentioned this in the channel, and it continues to be wildly true. Um, Anytime I ask a JavaScript question, I get 19 answers back. Anytime I ask a pseudocode question, every right answer looks almost exactly the same. That's the purpose of this. Because like a lot of the questions in the pseudocode thing have kind of like one reasonable answer to them. So why would anybody's code look different? That's sort of the purpose of this. And so there's a couple different awesome uses for pseudocode. The most practical of which is for yourself. Sometimes it's easy to get tied up in like the language constructs and stuff. It's a lot easier to just talk through a problem to yourself in pseudocode first. Another thing, it's a good lingua franca. If I'm working with a Python developer, if I'm working with a Rust developer, if I'm working with a C developer, we don't necessarily understand each other's language particularly well, especially any nuancy thing. Every developer understands pseudocode. And so it allows us to talk through a problem together in kind of a language neutral way. Another good reason to have some pseudocode under your belt, this is what you tend to do in interviews also. Somebody asks you a programming puzzle kind of thing. Pseudocode is generally a good go-to. Because it's that lingua franca thing again, where like you and the interviewer might not be familiar with the same languages, but you can follow logic together because this kind of logic is the same in every language. Initial questions about pseudocode before I just start doing stuff.
The thing that I've done most consistently wrong on this exercise is inputs.
Yeah.
I got no idea how to write those.
All right. Let me write that down. You're not the only one. Any other things you want to make sure get covered in this?
Just a quick question.
Mm-hmm.
So going through the operators, so you have like equals.
Mm-hmm.
Are we allowed to use like exclamation point equal for not equal?
Nope.
Okay.
The
Just want
things.
to check on that.
So I guess this is important to point out too. In general, pseudocode doesn't have its own syntax either. It's really just anything that makes the logic clear. For these assignments, you have to use Sika format. It lets you not hand wave away quite as much. It also gets you used to following very like precise instructions because if you get one phone number wrong, and it is a simplified version of the most popular formal syntax for pseudocode, which is called structured English. Awesome. So let's take a look at, since we're not allowed to use equals and some of those things, what are we allowed to use? Come on, old man Coberly, give us a break. So if I head over to the Sika pseudocode reference, here it is. I would recommend, especially as you're working through the pseudocode problems, like print this out. It's not that long. It'll make it a lot easier to refer to this kind of stuff. Because I don't want you like using a ton of brain power, like storing away the exact syntax for this. But I do want you to use exact syntax. So just referring to it here will help you out substantially. So for example, how do we do input? Like that. So that is how we do set something to is how you define a variable. Input is whatever the user entered. Now, this is like kind of a nuanced thing. So input means any input. So that could be the user types something and hits enter. It could be a parameter. It could be any other way that somebody might get data into something. All of that is input. But that's the syntax for that. How do we do comparisons if we can't do triple equals or the exclamation point? Let's see, that is, where is it? There we go. To do Boolean comparisons, and or not is not. So if you wanted a block to run anytime the age isn't 18, that would be if age is not 18. Another thing I've seen a lot on these submissions, hierarchy. So we don't do braces, we don't do parentheses, we don't do any of that kind of stuff. The way that we show that something belongs to something else is by indenting it. So all of, like this block runs if that's true, for example. We also have one for the entire program. So let's see, do I have an example of a whole program on here? Apparently not. So like everything would be indented in one level from the program. I've been a little bit more forgiving on that one. But yeah, there's not that many things you can do. And that's part of the point. You can make lists of things. They're not arrays. An array specifically has a method called push, a method called pop. But you can do collections of things. And these are the things that we can do with those. That's the equivalent of pushing something. This one works a little bit different because it takes in an index. That's how you can find out how many things are in a list. That's how you make a sublist. The only thing that you can do to loop is while. We can have object-like things. They're not really objects because we can't put functions or anything on them. We don't have any of the other stuff we can do with like JavaScript objects. But we can do key value pairs. So if I want a person dictionary, just start setting properties of it. So set this key to this value. If I want to read something, works the same way. And this is every single word in Seek a Pseudocode. If it's not one of those, and it's not a variable name, not allowed.
I had a question about the dictionaries part there, Kyle.
Mm-hmm.
A dictionary in pseudocode is a collection of key value pairs. So would that be like as far as like an actual JavaScript, would that be like an object?
It's exactly what it is.
Okay, gotcha.
And it's kind of interesting because in JavaScript, like a dictionary is like a normal data type. So is list for that matter. Many languages have lists and dictionaries. And what JavaScript calls an object is actually probably a little bit closer to a dictionary. So they're called, the same data structure is called a dictionary in Python. It's called a hash in Ruby. Actually, I take it back. Hash is a closer data structure to what JavaScript objects are. But all of those refer to effectively the same kind of thing. Key value pairs.
Okay.
And you can still treat it like one thing otherwise. Like person is still one container for some set of key value pairs. Also, none of the pseudocode problems that we'll work through have dictionaries in them. You do not need to use them. They may come in handy for like warm-ups or for your own problem solving, but you don't actually have to use these in any of the pre-made problems that I have. More questions? All right. Trying to think of one I want to demo this with. Let's do reverse a string. Or shoot, no, I'll do one of the actual problems, and I want you guys to do reverse a string. So I'm going to pull up the pseudocode exercises. And let's do all right, let's do this one together. No, I want the one where the running sum. All right, let's do the running sum together. So write pseudocode that will calculate a running sum. I'm going to copy this into the whiteboard. All right, so that's the problem. And then, I don't know if this will work with a whiteboard. I want to keep this reference handy. And all right, so let's say that I'm doing this in an actual interview. I would probably do something like the following. So I'm going to have a program, a little smaller. And I need to give this a name. So that means I need to understand what the problem is doing a little bit. Write pseudocode, check, that will calculate a running sum. How about calculate running sum? That sounds pretty good. Calculate running sum. A user will enter numbers that will be added to the sum, and when a negative number is encountered, stop adding numbers and write out the final result. Okay, so a user is always going to enter at least one number. So I'm going to look at the reference. How do I get input again? All right, set something to input. So we'll call it number. I'll do set. I'll do this in a different color. Set number to input. Okay, so that is going to take in a user's, whatever they enter. Now, this is also reasonable. I could take this, oops, almost. I could take this and also put in something for like output enter a number. I think that's fair. So I output enter a number. I save whatever they enter into number. All right, so now I got to think what the conditions for this are. We added to a sum. Okay, so I also need a sum. I need to figure out what I want to initialize it to. So that's going to be something like set sum to 0. We added the sum, and when a negative number is encountered, stop adding numbers and write out the final result. So I can actually skip to the end because I know how it should end. It should end with output sum. Now I just got to figure out what goes in between here. That's a smaller problem. It's a simpler problem. So when it encounters, ding, 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 that tells me that there's some kind of conditional that needs to happen. So, all right. And then the implication here is that they're entering numbers over and over and over again, and we're waiting to see when to stop. Hey, a while loop will do that. That'll let us do something an arbitrary amount of time. So this could be something like set or while number. It needs to go until it's negative. So while number is greater than or equal to 0. All right, what happens? Well, it takes the number and adds it to the sum. So that'll be, let's see, how do I do variable assignment? Head over here. All right, set to. So it'll be set sum to whatever sum currently is plus number. Okay, so that does it with 1. Now what? Now what? Well, in this loop, I could have them do all this again. So I could say something like, output, enter a number, and then set the number of the input again. Okay, and if that's the end of the loop, hey, that'll just keep looping back through here. So final step of problem solving is reflection. So we have to verify this. So I missed one of those. So probably should have done this first, but all right. So if a user enters 1, 2, -1, that should output 3. If they enter -1, that should output 0. If they enter 1, 2, 3, 0, -3, that should output 6. So I look through this. First one, Run the program. It outputs enter a number. Set number to input. First input is 1. So now that's 1. Set sum equal to 0. While number is greater than or equal to 0, it's currently 1. So that means this indented block runs. Set the sum equal to the sum plus the number. So 0 plus 1, that's 1 now. Outputs enter a number. Sets number to input. Next input is 2. So that becomes that. And then set sum equal to sum plus number. Sum is currently 1. Number is 2. So then sum becomes 3. Output enter a number. Set number to input, which is -1. So this becomes -1. While -1 is greater than or equal to, all right, well, that didn't work. So that's the end of that loop. So we output the sum, which is 3, which is our output. -1. Enter a number. Number goes to -1. Set sum to 0. While -1 is greater than or equal to 1, none of this block runs. So then we output the sum, which is 0. And then don't make me do the other one. So that's the idea behind pseudocode. Ask me some questions about it.
I have a question. It's not about this one specifically. So for this one, we're using user inputs, right?
Correct.
But if we're not dealing with user inputs, do we still set number to input? Will we still use that?
Yep. So if it's one of the ones like
I think the first one.
reads 2 numbers, yep. You could either write the output as give me the first number. Not necessary though. You could do that as like program multiply set first number to input. Like that's how you would do parameters effectively. That's the correct way to do that.
Okay, thank you.
You're very welcome.
I feel like there should be more to it, but I guess that's just the simplified take of it that we're doing.
There's really, even in like, the one thing that I intentionally kept out of this was the idea of calling other programs. Past that, that's all there is to pseudocode. So I also took out for each. That's like a pretty common thing in a lot of other pseudocodes. But nope, otherwise it really is just this. Now, what's tricky about that is a lot of things that you're used to, like, for example, sorting. Well, we can just dot sort. Yeah, not so much. You got to write out all the logic. So, like, this is an example of what that looks like in C. So you can tease out what the logic of this looks like, but you have loops inside of loops, basically, and a lot of conditional checks. So some things that would be crazy easy if you could write it in a programming language are very hard when you have to write out the logic of it. Reversing things is like that. Sorting things is like that. And so like it can really kind of clean up your thinking on how those things work. But yeah, I don't think there's very many pseudocode syntaxes that are more complicated than this. Like structured English is the biggest one. And like, what do you know? Looks an awful lot like what this looks like. You can also just do a little bit more stuff like this. That's like implied that you'll find some way to do this. Like if customer has a bank account. The overall structure of it, though, is still the same. More questions about pseudocode. Cool. Hope that helps. Was there anything else in here? It was just inputs, right? Yeah. Awesome. Okay. Study hall starts in 5 minutes. Elsewise, go learn something.